What if an AI could read an entire book, like in a split second, and have a perfect photographic memory of it? Well, that's not really science fiction anymore. We're about to break down a brand new technology that gives AI exactly that. And trust me, it is a total game changer. Let's dig in.
So we've all seen just how powerful large language models, LLMs, can be. They're amazing. But for all their brilliance, they've got this one fundamental weakness, a real bottleneck that gets worse and worse the more information you try to give them at once. It's a problem that's been driving developers nuts for years. The dream has always been pretty simple, right? Give an AI a huge document, a financial report, a whole novel, and it should just know everything inside instantly. But the reality? It's been a nightmare. It's slow, it's wildly expensive, and half the time it just crashes. This all comes down to something called quadratic attention cost. Now, think of it like this. For the AI to get the context, it has to compare every single word to every other single word in the document. As that text gets longer, the workload doesn't just grow. It explodes exponentially.
So, to get around this massive problem, developers have tried a few different workarounds. But as you're about to see, these so-called fixes often end up creating a whole new set of headaches.
The first approach is basically like cramming for a test. You just stuff all the information into the AI short-term memory, right into the prompt. It's a temporary fix, it's incredibly inefficient, and as you add more info, the AI just gets confused and its performance tanks. The second method is way more intense. You completely retrain the entire model on the new data. Sure, it's more thorough, but it can take hours, even days, and costs a fortune in computing power. Neither of these are good options for a real-time practical solution.
But now, a new paper has just revealed a totally brilliant breakthrough. It's a completely fresh way of thinking about this problem, and it solves it in a way that is surprisingly simple and, well, elegant. It's called Doc-to-LoRA, or D2L for short. And honestly, the best way to think about it is as an instant cheat sheet generator for the AI. Instead of forcing the AI to reread that massive document every single time you ask a question, D2L reads it just once, and in a flash, it creates a tiny, hyper-efficient adapter, that's the LoRa part, that permanently implants that knowledge right into the AI's memory.
Okay, so here's how it works, and this is the really beautiful part. You take any document and feed it to this little D2L network. In less than a second, it spits out that custom LoRa cheat sheet. You then plug that tiny cheat sheet into the main LLM, and that's it. It's done. The AI now has a permanent, internalized memory of that document and can answer questions about it without ever needing to look at the original text again.
Okay, that all sounds great in theory, right? But does it actually hold up when the rubber meets the road? To find out, the researchers put D2L through a truly brutal stress test. They used something called the needle in a haystack challenge. The goal is simple, but it is incredibly difficult. Hide one specific, totally unique sentence, that's the needle, deep inside a massive document of completely irrelevant text, the haystack, and see if the AI can actually find it.
And the results? Well, they're absolutely striking. Take a look at this graph. See that yellow line? That's your standard, very powerful LLM. As the document gets longer and longer, you can see its performance just completely fall off a cliff. It gets lost, it can't find the needle, but now look at that blue line. That's the same LLM, but this time it's equipped with a D2L cheat sheet. It maintains near-perfect recall, finding the needle every single time, even when the document is 4 times bigger than its supposed memory limit.
And here's the real kicker. The graph on the left, that shows D2L's perfect accuracy. We just saw that. Now look at the graph on the right. That yellow line shooting up into the sky? That's the standard AI's memory usage just exploding as the document gets bigger. But the blue line for D2L, it's almost perfectly flat. It achieves perfect recall while using virtually no extra memory. I mean, that's the holy grail right there, a total win-win.
And this isn't just some fluke in a weird controlled experiment either. When you put it to the test on real-world Q&A benchmarks like Squad, D2L, that's represented by those blue stars on the chart, it consistently hits that perfect sweet spot. It delivers top-tier performance, internalizes the info in less than a second, and uses a tiny fraction of the memory. It just works.
So what does this all actually mean for the future of AI? This is where things get really, really exciting. Because this isn't just a small step forward, it's a huge leap that unlocks entirely new possibilities we couldn't even consider before.
To really grasp how big of a deal this is, just take a look at this number for a second, 75.03%. By itself, it doesn't mean a whole lot, but the story behind this number is absolutely astonishing.
That was the accuracy score of a text-only AI on an image recognition test. Yeah, let that sink in for a minute. The researchers used D2L to take the knowledge from an AI that can see images, and they created a cheat sheet for a text AI that is completely blind. The text model, having never seen a single image in its life, was suddenly able to identify them with over 75% accuracy, purely from this transferred, internalized knowledge. It's wild.
So what does this actually unlock for us? Well, we're talking about truly personalized AI assistants that can instantly and securely learn your entire work history or all of your private medical records. We're talking about AI agents that can adapt to a changing world in real time. We can finally update our AIs with new information frequently and cheaply, breaking through those memory and cost barriers that have held them back for so long.
This technology effectively gives AI a superpower it has never had before: perfect instant memory. So it really just leaves us with one fascinating question. If you could give an AI a perfect instant memory of any document in the entire world, what would be the very first thing you would teach it?